Bandwidth for First Updates Now is supported by AndyMark. Are you competition ready? Go to andymark.com and keep your team inspired. And by the Blue Alliance. Keep up to date on all live and archived First Robotics events and team stats at thebluealliance.com. First Updates Now is brought to you by Twitch. Fun is now a Twitch partner and offering some awesome subscriber-only benefits. Subscribe today or get a free subscription each month when you have Amazon Prime by linking your account and clicking subscribe. Well, good evening, everybody, and hey, welcome to First Updates Now. We got a very special presentation for you here, where this is episode 3 of 4 of Fundamentals of LabVIEW, and we're delighted to have everybody here, and even more delighted to have April Reddit from National Instruments. Welcome on, April.
Hey, Tyler. Thanks for the intro. Yeah, like you said, my name's April. I work at National Instruments in Applications Engineering, and right now in First Technical Support, because it's build season.
Which means that she knows tons more about LabVIEW and RoboReels and all that fun stuff than I do, which is why we brought the expert on here. We can't wait to talk more about this. Speaking of which, April, do you mind kind of going through, as I mentioned, this is the third episode of 4. What have we gone through so far, and what can we hope to learn more about tonight?
Sure. So episode 1 was the introduction to LabVIEW, really covering the basics. How do you get started with a robot project in LabVIEW for FRC? Episode 2 got a little bit fancier. We started talking about vision control and vision processing, along with PID types of control, closed loop versus open loop, stuff like that. Tonight we're going to cover the command and control architecture. We'll talk about that a lot more in a minute. And then next week is going to be kind of a tips and tricks, fun ways to help you be successful with LabVIEW for FRC. We're going to talk about source code control, which I know is a huge topic, and a handful of other things that just didn't quite fit anywhere else.
Fair enough. And for tonight, the big thing, too, and we definitely think National Instruments, as they are donating another RoboReel. You guys are pretty crazy over there at NI. Pretty much they're become candy pieces now, the fun, and we're just delighted to have them, and hopefully you're delighted to have that chance to win as well. That will be given away later on during the show, and if you're interested in that giveaway, we will have a special keyword for you to type in later on, as I mentioned. You do have to follow or be a subscriber to the stream, and we definitely appreciate your support for that. If you can't afford a sub, you can do so for free through Twitch Prime. If not, just click that little follow button. We appreciate your support for that as well. Speaking of which, too, we're also going to have some cool trivia questions that April came up with during the stream. Those will come up. We got 3 of them coming up in between the stream, of which you can win some cool prizes from AndyMark as well. I know we have a couple shirts and a couple other things to give away from then. So can't wait to get into it. And speaking of which, if you do have any questions for April about the LabVIEW, about the presentation, anything that we're going over today, or probably almost anything else, I guess you can answer, go ahead and tag at First Updates Now. And we'll try to get those questions either during the stream or close to the end of it. April, anything else you want to talk about before we jump right into the presentation?
Not really. We're going to go through sort of all the slides at the beginning here, and then we're going to do about a 20-minute software demo walkthrough in LabVIEW, setting up command and control. It's a little bit of a long demo. I want you to stick with me. If you have LabVIEW installed, that's a great time to get out your computers, follow along. I just really want to walk you guys through the process of setting up command and control so you feel confident going into it.
All right, let's jump into the presentation then, April.
All right, cool. So this is National Instruments. Title slide. Again, this is kind of what we call advanced. This is a different architecture than your standard LabVIEW robot project, so don't be surprised when it looks a little unfamiliar. It won't look so unfamiliar in a little bit. And again, my name is April. So what we're going to cover today, really just talking about command and control. We're going to go do it through an overview, look at the architecture of the Project Explorer window, because that gets a little more complicated. How do you implement a subsystem? How do you create new commands? And how do you create your own subsystem? And we'll take questions at the end after that software demo, or kind of along the way if you want to sprinkle them in. So looking at what is command and control. Command and control is sort of the recognition that FRC robots are built up of relatively independent mechanisms, right? You have your drivetrain, you have your shooter. If you're shooting balls like we were last year, you might have an arm or a gear pickup or a power cube pickup. Each of these is referred to as a subsystem, and they each need code that will coordinate the various sensors and actuators of that individual subsystem in order to complete the requested commands or actions such as close a gripper or lower the arm. One of the key principles of this framework is that the subsystems will each have an independent controller loop that is solely responsible for updating motors and other actuators. It means a lot of this is running in parallel, so you're not tying up your main control loop with getting sensor data or sending a specific command to a motor at one specific time. You can do a lot more in parallel with command and control. So kind of an example of that, the core idea behind command and control is that code outside of each particular subsystem can issue different commands that can change the overall robot's output, but should not directly change any outputs of each individual subsystem. So they don't really affect each other. The difference is subtle, but this means that outputs can only possibly be updated from one location in the project. This really speeds up debugging a misbehaving robot because it gives you the ability to look back through the list of commands you sent to each subsystem rather than searching through your project where you might have modified that one output, but it could have been in this VI or it could have been in that VI. It also becomes a lot easier to add an additional sensor or change your gearing or disable a mechanism without needing to modify any code outside of that specific subsystem. You can go ahead and click to the next slide. It's going to look real similar to that slide. So robot game code pretty much consists of autonomous and teleop, typically needs to update set points and react to the states of different mechanisms on your robot. For autonomous, it's really common to define the robot's operation as a sequence of operation, right? Drive over here, pick this up, carry this here, drop it off here, etc. These commands can be wired sequentially with additional logic to quickly build complex routines, such as deciding, oh, I want to go to the left side of the switch or the right side of the switch. I can make game relevant comments now. This is really exciting. But yeah, so things like that can help you build these complex routines. For teleop, these same commands, go left, go right, pick it up, put it down, can execute asynchronously, which allows the robot to always be processing the latest driver inputs, and if implemented properly, new commands will interrupt, allowing the drive team to quickly respond to changing field conditions while also taking advantage of automated commands and command sequences. So in the example we have here on the slide, we're assuming that, our auto operation is going along, we're feeding it a 1, that's the value we want to send to the motor, right? And then all of a sudden we have to e-stop it for some reason. So you hit that space bar to e-stop your robot, and that e-stop command is going to override the autonomous code that's already running. So that's kind of the idea behind command and control. Why should you use command and control? Command and control really adds functionality to the existing LabVIEW project templates. It allows code to scale better with more sophisticated robots and robot code. Subsystems are used to abstract the details of the implementation, and the game code can be built up from sequences of higher-level command VIs. The commands themselves are the VIs that update set points, perform any numerical scaling or mapping between engineering units and mechanism units, or offering synchronization options. If physical changes are made to the robot, such as adjusting a gearing ratio, these changes can be made to just a couple of VIs to implement this change across your entire code base. So it helps abstract that detail, abstract the details of the implementation. I/O encapsulation it helps make for a more predictable operation and quicker debugging when resource conflicts do occur. I/O encapsulation is basically repackaging your inputs and outputs into their specific subsystems, so you know where they all belong and who they belong to. So because each command is an individual VI, you're able to single step through these different commands or use the built-in trace functionality to view a list of all the commands that were sent to each subsystem. The framework uses asynchronous notification and consistent data propagation to make it easy to program the sequence of commands or add in simple logic to determine the correct command to run. So you can really easily, and we'll see this a little bit later, but add in a button press to say, hey, if I'm pressing this button, do this. If I press this other button, I want this totally different functionality to happen, but I want that transition to be seamless. And that's what we're going to look at. So command and control is really built. It's a subsystem-based architecture, and it's built on these subsystems, and each of these subsystems will be a drivetrain, or a gripper, or a climber. And then each individual subsystem will have individual commands within it. So let's go ahead and get started looking at this. Some nice title slides this time. But getting started, when you want to create a command and control robot project, you do have to make a new robot project. There's no way to port an existing robot project just straight over into command and control, but a lot of the code you've written will be copy pastable into command and control as long as you put it back in the right spot. So when you're on this getting started screen, again, name your project something a little bit better than 2018 robot project. Put your team number in there, and you'll want to pick the command and control radio button, which will be the second button this year. So let's go ahead and start looking at the Project Explorer. Looking at the Project Explorer, when you first open it up, you'll see that it looks a little bit different than the Project Explorer that you're used to looking at. If you're familiar with the standard LabVIEW robot project, you're going to have a few different folders here. We've added folders for data, drive, which is a subsystem, framework, support code, and vision, along with the subsystem's VI. You'll also end up with an additional folder for every subsystem that you add to your project. So if I were to add a subsystem for a climber, I would have another folder called climber, and then it would have folders inside of it. So we're going to go ahead and look a little bit deeper into each of these folders and what they contain, because a lot of the strength and ease of use of command and control is really into using the Project Explorer effectively. So on the very top, we'll just go top to bottom on the Project Explorer. My computer is up there like it always is. You can still use it as a simulation target by changing what target you're deploying to from robot main. We talk more about that in episode 2. And that's where all the simulation support files live. Again, sim support files are in there. That has the 3D CAD files and the description files for the simulated robot. You don't really need to be poking around in there. Don't put your CAD files in there. It won't do what you think it does. Just don't mess with sim support. The Robotics simulation README documents all the PWM channels and robot info if you want to write code that matches the wiring of the simulated robot. It says, hey, PWM1 is connected to the front left wheel, stuff like that. This is really helpful if you're trying to learn LabVIEW and you might not be programming your actual robot in LabVIEW, but you want to try programming that simulation robot. So the dependencies just show any of the files used by that simulated robot code. Again, this gets populated when you actually deploy code to the simulated target. Build specs, same idea as the build specifications for your actual robot, your RoboRio target, but for your simulated robot. So before we start talking about drive, we can go ahead and do the first giveaway if you want, Tyler.
Yeah, we can start that up. So we're going to bring up on here in just a moment the first trivia question. Do you want to go ahead and read it, April? And real quick before we do that, just a reminder, if you're interested in answering the trivia question, go ahead and type that in chat. You can do it as many times as you want. You still only get one entry, but it's one time we don't mind if you spam a little bit. You do have to make sure you do follow or subscribe to be entered, and we'll draw that in a few minutes. So go ahead with the first question, April.
All right, the first question is, it's a fill in the blank, changing it up a little. Command and control is a blank-based architecture. One word.
So command and control is a blank-based architecture. Go ahead and start typing that in the chat. Once again, you do have to be a sub or a follower. And by the way, thank you to Aquinlan82 for your Twitch Prime subscription. Thank you.
Awesome. So that's the first trivia question. What are they winning?
Oh my goodness. Tell you what, let me rain check that for a second. I'll get back to it once we do the giveaway.
All right. We'll come back to that in just a little bit. give you guys a chance to do a great job of spamming chat with the answer to that question. So looking at the Project Explorer, we're going to look at what your typical subsystem folder looks like. So we're looking at the drive subsystem, and this is what comes in the default project in the example. As soon as you open this up, this is what you're going to see. So in the drive folder, you're going to have two more folders. You're going to have commands, and you're going to have implementation. So this is where those specific commands will live related to the drive subsystem. This kind of is a custom replacement for the WPI-lib robot drive VIs. Is kind of what we're building up here, is our own kind of customized robot library of VIs. And each subsystem is going to have its own folder hierarchy. Goodness gracious, I'm looking at the picture and not reading my slide. But yeah, so the commands are going to be all of the VIs that actually are the actions you want your robot to take. And the implementation is sort of the support code and the back-end stuff, and your main controller VI, which we'll talk about more in a minute. Cool, so looking at the framework, the framework is where all of the VIs live that are not part of a subsystem. Again, you don't often have to do anything with the framework folder, it just kind of sits there and holds all of these VIs. These VIs are going to look familiar. If you're familiar with the standard LabVIEW robot project, you have begin, that's called when the robot first starts. It's useful for initialization code that doesn't belong to a particular subsystem. So your joystick, stuff like that still lives in begin. Your motors are going to belong to their own subsystems now, which is pretty neat. Disabled, same as it always is. It can be used to debug sensors when you don't want the robot to move, but pretty much leave it alone. Finish, this is called more during development. This is where you can close all your references, clean up any code you might want to do there. Periodic tasks is typically where we used to put sensors. Those are going to go live in subsystems now. You can put other stuff in there. And then robot global data is useful for sharing robot information that doesn't necessarily belong to a subsystem, but typically everything goes in its own subsystem, kind of from here on out.
Hey, April, I just want to jump in while we're starting the trivia question. The giveaway for the first one is going to be a Join the Robot Revolution t-shirt from AndyMark, which is up on the screen right now. So make sure you type in the answer. We're not getting as many. This is a tough question here. So, but command and control, command and control is a blank-based architecture. So make sure you type in the answer for that, and we'll draw that in just a couple minutes here. You make it so hard, April, I tell you.
I know, I'm sorry. I stepped it up this week, guys. Let's step it down a little next week, don't worry. Okay, so moving on, looking at the Project Explorer, talking about support code. This folder contains any debugging and code development aids. This is where if you make helpful little VIs, like a convert meters into inches, or I guess the other way around would be more helpful, things like that, those can live in here so that they can be independently used by different subsystems. It's a great place to put them. And then again, your vision folder only has that vision processing VI. We talked about this back in episode 2. This is where you're going to add any custom vision processing code that you want to do. Still goes in the same place in that vision processing VI. You do have to edit that VI if you wanted to do any vision processing. We don't give you any code there. So looking at kind of the whole Project Explorer, kind of external to any of the folders, these are where your main level VIs needed to run the project live. So your robot main, still the same as it always was. That's your main control VI that's running. Teleop and autonomous, again, same as they always were. Test VI, this is what gets called when the driver station is in test mode. You might have seen that on your driver station. We talked about it a little bit in episode 2. This is that VI that gets called. And then subsystems VI is new for command and control because subsystems are pretty important for command and control. This is the VI that contains and starts all of your independent subsystems that build up to be your entire robot project. Dependencies are just the files used by the robot project that you need to include in your build, and then build specifications is where you go to right-click and deploy your code. So looking at the drive subsystem, let's get a little bit more into the commands and the implementation. So like I said earlier, this folder contains all of the command VIs that request the controller to carry out an operation. It also contains the templates for creating additional drive commands, and we'll look at how to make a new command later because we do give you these templates, and it's pretty important that you use them. Yeah, the other thing you might want to edit is kind of in this main folder or down in implementation, is after you create a new command, you might need to edit the drive setpoints.ctl. You see it at the kind of the very bottom of this page, this image. This is where you can add and update fields that the controller uses to define the new operation. You would also then need to go into the drive controller VI and modify the case structure to add a case for every value, and I will walk you through that. So stay tuned for that. So looking at the infrastructure VIs, these are the VIs that support the subsystem functionality. This is kind of what helps make all of it work. So drive check for new command. This is called each iteration of the controller loop. It's literally checking for a new command, updating timer data, and upon completion, it notifies the next waiting command that it can go ahead and run. You're going to see that these VIs will be called whatever your substructure or your subsystem is. So if I made a subsystem called shooter, it would be shooter check for new command, etc. The command helper, commands call this VI to say that a new command has been issued. They literally go, hey, I'm a new command. Take note of me. And if it's an important command, that's where it overrides. And the controller initialization allocates the notifier and combines the timing, default command, and other information into a single data wire. So like I said, this is all kind of background stuff that's happening to make sure everything works. You don't need to edit any of those VIs. But I wanted you to know what they do, so they're not a mystery.
All right, April, why don't we do the roll for the first giveaway in here? So once again, the question was, command and control is a what-based architecture? What is the answer to that one? You said it a few times.
It is a subsystem-based architecture because it is built on subsystems.
And the winner for that is Gray Phantom Delta. Gray Phantom Delta, you have won the Andy Mark t-shirt. Please shoot me a message, and we'll get that out to you. Congratulations.
Awesome. Okay, so we talked about the VIs within infrastructure. The rest of the VIs in that implementation folder. The controller VI contains the control state machine loop. This panel, the front panel of this VI, is really helpful for debugging. This is where you're going to actually put all of your code that does stuff, and we'll get to that. The operation control, the .ctl, is just a control file. This is a type def, which means that when you edit this, if you have it used anywhere, if you've copied and pasted it into another front panel, it will update as well. So this defines the operational modes of a controller. You can have the same named operation in different controls, in different subsystems. Again, the set point control just contains all of the data fields that any of your modes in your subsystem or your commands might need. So if you have a set point and a duration and a height, you would have to edit that to add the height in because that's not default. And then the published globals is as a useful place for publishing, again, global information that is relative to only the drive system. This is the drive subsystem. This is different from the robot global VI, the robot published globals. That's for information that the whole robot needs. If only other VIs within the drive subsystem need the information, you can put it in the published globals VI. So let's look at initializing the drive subsystem. We're going to kind of go through the default code, and then we'll go and set up our own subsystem here in a minute. So looking at initializing the drive subsystem, this is inside your drive controller.vi is the VI we're looking at on the screen here. The area to the left of this control loop, which is that while loop you see the little edge of on the right hand side of this picture, will execute once the subsystem starts up. This is where you will allocate and initialize all I/O and state data. You can see we're setting up a motor here. You can publish the I/O ref nums, or you can register them for test mode only to keep them private so other code can't update those motors without a command. There are green comments kind of all across these block diagrams that point out key areas that you'll want to know how to edit, so pay attention to anything those are pointing to. It's worth noting that initializing the resources in each subsystem, so in their respective controller VI, rather than in the begin VI like we normally do, improves the I/O encapsulation, which reduces potential resource conflicts and simplifies debugging. So you know that if you're talking to, I don't know what PWM this on, whatever PWM channels that motor is on, you know that if it does something, it came from the drive subsystem or it came from the climber subsystem, which makes it a lot easier to debug your LabVIEW code. So looking at the next slide for initializing the drive subsystem, you want to select the default operation and set default set point values kind of in this brown cluster, which we have here on the left. This is what your command will do, what your subsystem will do when no other command is being processed. So when it's not getting anything from you, this is what it's going to do. Typically, you put it to the reserve state, and that's just a kind of all zeros, neutral, not doing anything state. So it's not, you know, randomly driving across the field when you don't tell it to go somewhere else. So looking at the next slide, this is the case statement where we're actually going to implement our different operations. This is where you can change the set point value, the iteration delay, the iteration count, use some sensors to change how your system reacts. The case structure is going to have a value for each operation state of your subsystem. So here we're looking at the drive for time state, and you can see that we've taken our set points and wired them out. And we're doing some kind of clever stuff with the time there to determine if we've reached our duration time or if we need to update again and repoll. We're polling every 50 milliseconds here because we want to keep the safety configuration on the motors happy. So that's kind of why we're doing some clever timing stuff there. Looking at the next slide, this is really kind of what's cool about command and control, is updating this trace. You can see the VI called in the lower right-hand corner there. Each iteration of the controller loop will, if you tell it to, update the trace VI. The framework already incorporates the subsystem name, operation, description, but you can find it really helpful to format additional set point values into the trace information. You can open up that trace VI and click Enable while the robot code is running to see current set points and commands being sent to each system. So you can actually see in real time what you're telling your robot to do, whether you're telling it to go faster, go slower, extend an arm, shoot a ball, how fast are you spinning those motors to shoot that ball. You can see all of that in real time and know if your code is executing the way you want it to or not. Because we definitely don't want to get close to that safety timeout, because if we miss it due to execution time or your vision processing loop is slowing everything down, if we miss that safety time point, it'll actually time out all your motors. So we definitely want to make sure we're updating it frequently enough to catch that safety timeout, basically. We're just playing it safe here. So initializing the drive system, the primary goal here, once we get past that while loop, you can see that case structure in the lower left-hand corner. This is really hard to take screenshots for because I wanted you to be able to read what I'm talking about, but also you kind of have to look at the whole code, which is why we'll jump into that here in a minute. But this is where we're actually going to update our actuators for the subsystem. You can see here, hey, we're setting these set points to the motors. It's beneficial to do this outside of the case structure. This ensures that the values are always updated with the correct value and in only one location in the code. So this is the only place I'm ever writing to those motors. So if they're doing something wonky, I know it has to come from here, and I can trace it back to find out what's going on. yes and no. You can update different modes differently, like at a different rate, and you can tell them to update at a different rate. I typically poll all of mine sort of on that 50 millisecond kind of clock, just for my own sanity, so I know when things are updating. But if you want something to do something for 3 seconds, you can establish a like a drive for duration VI and tell it to continue executing until your 3 seconds is up. So it'll just keep running that same command over and over until it has gone through 3 seconds.
And I just realized I was muted to everybody else when I asked that question. So just give credit and just to know what the question was in the first place. The question from Levinsick1 asked, can you use different time slices for different modes? So that was the question April just answered there. Sorry about that.
It's all good. So let's go through the drive subsystem shipped commands. Yeah, let's go through the drive system shipped commands. These are the commands that live within the controller for the VI. And that controller VI is the main VI that contains all of the commands, and that's where you're actually doing your subsystem setup, like we talked about. That's where you're doing all of your initialization. So looking at the drive subsystem shipped commands, we start you with drive for time. This sets the motor to run for a given number of seconds. You can optionally synchronize this with the completion of the command, so you can get like a signal that says, hey, I drove for 3 seconds, what do you want me to do next? And you can already have that next command queued up and ready to go. So as soon as you're done driving for 3 seconds, you're doing something else. Looking at the next slide, again, this is that block diagram we saw. This case operates the motors at the set point for the duration of this case until the timer elapses or a new command is issued. So this is overridable. So if it gets a new command that says, hey, stop, I'm about to run into another robot, it's going to stop. If your motors have that safety timeout enabled, it's necessary to update the motors at least once every 100 milliseconds, like our commenter pointed out. So this code is waiting for the smaller amount of either the remaining time or 50 milliseconds. So it's going to wait 50 milliseconds, tick over, see if it needs to wait 50 milliseconds or less, and then continue ticking over like that. So the next shipped command we want to talk about is drive immediate. This sets the motors immediately to the desired speed. This is typically where we're going to see your wire through from your joysticks, is this drive immediate command. You can see that we've just taken the left and right set points, wired them across, and then the motor set VI is off to the right there. Again, we're only holding the motor value for 50 milliseconds at a time, so we don't upset the the safety configuration timeout. So every 50 milliseconds, it'll check, say, hey, I'm still driving immediately. I'm going to grab those set points and set them to the motors. So this command doesn't really finish, per se. It's going to kind of continue iterating until we get a timeout value or we get a new command. And then the last VI that we sort of ship you with is stop driving.vi. As you can probably guess, this sets the speed of the motors to 0 instantly. You can see there that we don't even wire our set points in because we want this case to set it to 0. We don't care what the inputs are. We don't care what the joystick is doing. We want that robot going nowhere. So it turns off the motors and it sits here waiting for a new command. So you can see that this case is actually called reserve. This is that default case I was talking about that's just sort of always good to set as a 0 point, as a safety thing. Do we want to do the next trivia question?
Yeah, let's definitely do the next trivia question. And the winner for that, I'm prepared this time now, by the way. So the winner for that is going to get a set of compliant wheels from AndyMark. You can choose if you want a 2-inch or 4-inch compliant wheel. Will be up to you because they didn't tell me which one, so I'm just going to let you guys pick and hope they're cool with that. So, but with that said, we'll start the second trivia question in just a moment here, and we do also have a question, April, I want to catch up on here too.
Sure.
But let's start out with what is the second trivia question?
So the second trivia question is, what is the name of the VI in which each subsystem is set up? So this is the VI where you're doing the initial configuration for each individual subsystem.
All right, so if you're interested in that, if you know the answer, go ahead and type that in the chat. You do have to follow or sub, and we appreciate all the people who have subscribed so far to help support First Updates Now, but we appreciate your follow regardless. So make sure you type in the answer in the chat. We'll post that in the chat, too, what the question is in just a moment. So, April, there was another question from Levinsick1 who asked, if you are pulling a gyro or something, is that a separate subsystem, or does it live in timed cases?
It lives inside these cases. So you're actually going to pull that within each individual subsystem. So, which is neat. It gives you a lot of capsulization of your entire drivetrain or your entire arm or things like that. Cool. Well, while you guys are hopefully answering that trivia question, maybe I made them too hard. Oh no. Sorry, guys. We'll go ahead and start talking about creating new commands. And then, unless I need to re-ask that question, Tyler looks really worried.
Oh, no, we're good. I'm trying to put the question in the chat, so...
Well, okay.
Just keep on going. I'll post the question in the chat, and people can do a little bit of homework, maybe, to get the correct
answer. These are all searchable via your favorite internet web search engine. So, looking at creating new commands. When you want to create a new command, you want to open the subsystem commands folder in the Project Explorer window and choose one of those VI templates to use as a starting point for your command, and then right-click and select New from Template. That's what we're showing here on the screen. It's how you get to that. We're going to talk about those 3 templates here because there's 3 different kinds of timing that are involved with command and control. There's the immediate timing that we talked about. This VI notifies the subsystem about the new set point immediately. So as soon as you move that joystick, it goes, hey, here's a new set point, and feeds that to the subsystem, which then does whatever you've told it to do with it. There's immediate with deadband. So what this does is it compares the new input value to the deadband value and optionally notifies the subsystem if it's outside of the deadband value. This is really useful when you're using those joystick continuous values because when your joystick is sitting in its neutral position, it might actually not be truly neutral. It might be sending 0.01 or negative 0.01. And this is really easy to see when your robot is sitting there, but your motors are kind of growling or making that grinding noise that's really pleasant. This is how you know that you're getting a little bit of deadband sent to your motors. So building a command off of immediate with deadband can help cut that out and actually send a true 0 or a true value to your motors and not wear them out as quickly. The third kind of timing is with duration. This notifies the subsystem to perform this command for a given duration and then return to the default state to await the next command you send it. Synchronization determines whether the VI starts the operation and returns immediately or waits for the operation to complete. The first option is commonly used for teleop, where you want to start the operation immediately, and then the second option is commonly used for autonomous, when you want that to sort of drive for 3 seconds, lift something for 1.5 seconds, those kinds of things if you don't use limit switches or something else, some other kind of signal within your robot.
So, April, I just want to get in. I don't know if I've seen a correct answer yet, because a lot of people go on top of each other. When they see one, they think it's the rest. So,
I made it too hard.
Maybe so. Do you want to? Can we ask that one more time and maybe get a little bit of a hint or clue or something?
I'll rephrase the question. Same answer. What VI actually contains all of your operation code for each subsystem? So each individual subsystem will have this VI. It'll be called, so for like the drive, it would be called drive blank.vi. And this is where you would actually go in, set up your motors, set up your configuration type stuff, tell it the commands you want it to have, and send those to the motors.
All right, I might have seen one answer come through, so we'll see. We'll see what it is on there, and it is. I don't think you have to put in .vi. I don't know if that affects it or not, but
no, it should just be the word, one word.
All right, so we're starting to see a few answers. We'll see how that works out or not, but we'll go through a couple more slides, and then we'll draw for a winner.
Okay. 10 letters, I think, if I can count.
Now that's a huge hint.
If that helps. Yeah, 10 letters.
Yeah, these are definitely
I can
harder
count.
this time, so that's all right. You know what?
Gotta
There's
step up
nothing
your
wrong. You don't
game.
get free. We're giving away free stuff, guys. Do a little bit of research. Come on.
These are compliant wheels. These are useful for handling those power cubes.
Yeah, no kidding.
So, you got some implementation now. These aren't just, yay, compliant wheels. Alright, great. So, we talked about the 3 different kinds of timing, immediate with deadband, and with duration. So, if we wanted to look at kind of an example here, yeah, we'll go through this quick and then I'll walk you through the actual process. So adding the command for drive for distance. So we're going to go ahead and walk through this. We're going to choose the drive with duration template because we want it to go a distance, and going a distance takes a set amount of time. So we're going to save this VI with a descriptive name like drive for distance. So looking at the next slide, we're going to go ahead and add the new command to the drive operations enum type def, and I'll show you guys how to do this. But you would just open up that drive operations.ctl from the Project Explorer window, right click on this enum dropdown and select edit items. You'll be able to type in whatever you want to call your new command. Make sure it matches, make sure it's reasonable. So, and this is what that drive set points .control looks like. This is where you need to add any additional information. In this case, we've gone ahead and added the distance in feet because we want to set for a distance, not really a time. So we're going to go ahead and add that to this control and save it. So once we've gone through, added that, and we have all of the fields needed to specify our command, we can go in and modify the newly created drive for distance VI. So as you see here, we've selected the drive for distance in that initial cluster, that big brown box at the top. Drive for distance. Creating new commands. It doesn't say example, it just has some code on it. Cool. Oh, sorry. These go kind of quick. So looking at the code on this slide, we've selected the drive for distance dropdown. It should be in that blue dropdown enum now. We've already modified that control. You can see the rest of those are zeros because those are our set points. And you can see here that we're doing a little bit of math, right? We say, hey, we're going to give you distance in inches, but we want to know how many inches are per foot. So we say 12 to multiply that out into the inches that the subsystem is requesting, even though we want to give the subsystem a distance in feet. Because it makes more sense to say, hey, I want my robot to go 15 feet than whatever the equivalent would be for inches. That's really all you need to do in these command VIs is make sure that your inputs are going into the subsystem correctly. Don't worry about the telephone, don't mess with any of that. That's all the structure code that makes sure your calls get sent to the subsystem. So going to the next slide, we're now going to go back to that drive controller VI to define what happens when the drive for distance command executes. We're going to right click on the case structure, it's smaller now, and either duplicate or add case for every value. This will add the drive for distance case. Looking at the next slide, you can then implement whatever code you want to happen when you say, hey, execute the drive for distance VI. You can see that we've expanded the uncluster menu to add that new set point. We've added some encoders. We're opening those outside the loop now. You can see we've added that code over there and things like that. That's basically how you go through and make a command. If we want to answer that trivia question.
Yep, we can go ahead and answer the trivia question there. Do you want to? I'll let you ask the question because we could have reworded that to help out a little bit. So go ahead and provide the answer for that, and then we'll do roll for a winner.
Sure. So the first question was, what is the name of the VI where each subsystem is individually set up? And the answer is in the controller VI. So your drive controller or your lift controller or things like that.
Yep, so if you did controller or controller VI, then you won. And our winner for the compliant wheels is going to be Eric Leiferman, 2826. Congratulations. Shoot me your information, and we'll get that sent out to you. So congratulations for winning the compliant wheels from AndyMark.
Awesome. All right, I think we'll go ahead and jump over to the demo, the code demo, and we'll go ahead and walk through that. I think that's more valuable than going through the 3 slides of generating the subsystem. But they're in there. If you guys look at this later and you want to walk back through it, they're in there. The information is there. Yeah.
All right, we got that up on screen for you, by the way.
Great. Cool. So this is LabVIEW FRC 2018, newly updated, bright and shiny. So we're going to go ahead and make a new FRC robot project. We're going to call this Command and Control 2018. That's a good name. We'll be team number 1, 2, 3, 4. And then we're going to go ahead and select the Command and Control option here. And this is going to tell LabVIEW to generate that Command and Control project. So I'm going to click Finish. It's going to go and configure and go ahead and open this up for me. So you can see here we have all of those different folders I talked about earlier. Robot main is still here. If we open this up, it's opening slowly, surely. Go ahead and tile it. So you can see here, this is our normal robot main. Our icons in here look a little bit different. So if you're seeing these, you're in the Command and Control architecture. You're in the right place if that's what you want to be doing. This is kind of your first indication that something has changed a little. But looking at our Project Explorer window, which is back here, we want to go ahead and make a new subsystem. So we're going to right-click on our RoboRio target, select New, and you'll see that you have a new option here called Subsystem. So you're going to click that. Let's pick a relevant subsystem. We're going to say that my robot has one mechanism that both lifts a power cube to the scale and climbs on the bar at the end of a match, because I know what I'm doing. So we're going to call this our forklift. Oops. I can spell, it's not a fork light. We'll pick a nice icon color so LabVIEW can go ahead and match all of these icons. We'll go with a nice purple. I like purple. So any operations you put here in this box are operations that will go ahead and be automatically added to your project. So let's say when I'm starting to write this, I know that I'm going to have a lifter, a lift option, and a climb option, right? These are 2 operations that I know this mechanism is going to do. So I click OK, I say great, it's going to go ahead and open this up. And it goes ahead and opens up your controller VI for you. So you can see that this is called forklift controller, and it's just sort of the default here. So if we Control E to open up the block diagram, and we'll go ahead and maximize this. Your block diagrams do get a little bigger here. Bear with it, it's fine. So looking at this, here is our main control loop down here. This is our case structure where we're going to add all of our code. This is where you can put your sensors up here if you want to run them a little bit faster. This is a 20 millisecond loop, and you can send values out of here to down here through these clusters. So let's go ahead and add our motor. You can see I have our motor control palette already open over here. I'm going to go ahead, open up a new motor. Sure, it uses a Spark controller. Right click and create a constant. We'll say this is on PWM 9. My drivetrain is on 0 through 3. We'll put this down on PWM 9 away from those. So looking at that, we're going to go ahead and set our motor name here. So we'll drop this VI out here, wire over the motor data. We'll wire over our error wire as well, just so we know if we don't find this motor controller for whatever reason, our code's going to stop there. Right click and create a constant. So we're going to call this motor forklift motor. Spelled forklift right this time, guys. It's getting better all the time. So we've gone ahead and set this. Great. And the last thing we want to do is enable our safety configuration because we want to be safe. We don't want our robot running around the field randomly if something happens, if it stops getting commands. So we're going to go ahead and create a constant on the mode option and make sure that that is set to enable, not disable, and call it good. So after we get all that set up, we're going to go ahead and wire this in here. And then I'm going to go ahead and put our set output VI over here so I don't forget to do it later, because this is actually the VI that sends the value out to our motor. You see that we have this diagram disable structure over here, and it has a network table publish VI inside it. You can actually right click on this and say remove diagram disable structure. This is basically how you comment out code in LabVIEW, is through a diagram disable. Click on that and you can see that now it's not shaded anymore and we can access it as per normal. If I wanted to send this information back to the driver station, I can right click on the name, create a constant, call this forklift motor data. Descriptive names are always good. Put this up here out of the way. And then when I actually get my value out here, I'll wire it into this VI to send it over. Cool, so before we jump into actually setting up our commands, let's go ahead and do that third trivia question. Now that we're in the middle of a software demo, it'll be great fun.
Sure, yeah, we can start that. Give me just a moment here. I wonder if it's going to be as difficult as the other ones. We'll see.
I believe in you guys.
I like the challenge. I think it's great. So
I think this is the easiest question out of the three.
Yeah, so if you guys don't get it, you know what that means.
If you've been paying attention, this should be hopefully easier.
All right, give me just a moment. Let me bring up the giveaway here. All right. Yeah, go ahead and ask the question, April, and I'll put it up on the stream.
All right. So, what type of command timing notifies the subsystem about the new set point as soon as the set point is set?
So go ahead and put that into chat, what you feel the answer is. And if we don't get anybody right, we might give a clue afterwards, but you'll see. And until, how many minutes in activity? So with the trivia question, make sure you do either follow or subscribe for your chance to win. And this one, we're going to be giving away another AnyMark Robot Revolution t-shirt, which we'll bring up on screen here for you so you can take a look. If you haven't seen it, it's pretty sweet. Modeling the famous Andy Baker as well for that. So you have a chance to win that if you type into chat. So go ahead and ask the question one more time, April, and we'll see what we get for a response.
So what type of command timing notifies the system about the new set point as soon as the system is set? So as soon as you move that joystick, it's going to get this value.
So I did see.
What type of timing is that?
There's been a few answers. I did see one that was correct, maybe one or two that was correct already. So we'll see if it goes through. I think there are 4 people, maybe 4 or 5, who have it correct right now. So we'll run that for a little bit. And don't forget, you do get there's no way for me to really dictate how many guesses you get, so you can probably guess as many times as you want and see what the right answer. I'm being honest. See what the right answer is.
I mean, there's only 3 options, so if you can either look up or remember what the 3 options are.
That's a fair point.
You have a 1 in 3 chance of getting it right.
All right, what are we talking about next on the live demo, April?
All right, so looking at the live demo, we've gone ahead and set up our motor outputs. So if we look at this case structure, we can click on this drop down, and you see that right now we only have 2 cases here. But I told it I wanted to make some commands, right? So I can right click on this case structure and go to add case for every value. When I click this, like magic, we're going to have more cases. So you can see here that we have our lift and our climb cases in here now. One thing to note is while you're, you typically don't need the read current case, so I usually go and delete that case because I don't want a command called read current. And when you're programming command and control, your run arrow up here will be broken for a little bit. That's normal. We have undefined outputs over here that we need to go and define before that run arrow will be solid again. It's also a nice indication that you've actually finished wiring everything because that run arrow will turn white. So looking at our 2 cases that we've added, lift and climb, if we're lifting, we're saying this is us picking up the power cube. Probably when we're doing this, we don't want our motors going super fast, right? I don't want a full joystick and the power cube just flies off into the air. That would be terrible. So we're going to add a slight reduction to our motor speed here. So I'm going to go ahead and grab a multiply block, drop this in here. Our set point here is the value coming into the subsystem. So this is going to be our joystick value. We'll go set that up in a quick second. And then we're just going to create a constant. Ooh, not a control. This is not what I want. To create a constant. That one. We'll set this to 80%. So this way, whatever joystick value I'm giving the subsystem, it's going to be automatically reduced to 80% of that value, which can help you just have more control over whatever you're doing with your motor. Now we do have to do something with the timing down here, so I'm just going to click over here and say, hey, this is my check if it's been 50 milliseconds or not code. I'm going to copy that over and put it over here because I'm not doing anything for a specific time. So I'm just going to put that down there. Carefully wire it back up. And then drag that across. I can just drop a 100 here. This is the default wait time, and since our motor timeout is 100, we wanted to move on at least at that point. So we did that, great. That's all we need to do for our lifting mechanism, right? We just want it to take the joystick input and lift for at 0.8 rate of the motors. So now for climbing, okay, first thing I'm going to do is go ahead and bring this code in, because we're going to need it anyways. That's a nice thing about LabVIEW. You can reuse a lot of code that you've already written, and it just goes very quickly. So you're going to create a constant, drop the 100 in there. And then for our motor output, say we did some testing and we found that when we go to climb, we just need the motors to operate at 90% of their total capacity the whole time we're climbing. So we're just going to go ahead and put in a 9, and the whole time this climb command is running, we're going to be operating at 90% motor capacity. This is a good idea to not operate at 100% motor capacity, because that's how you can get to brownouts and things like that, which are not good when you're trying to climb a 7-foot tower. So we're going to set this up in a minute to actually read in a button press. So ideally, as long as I have my climb button pressed, my robot will be climbing, regardless of what I'm doing with my joystick. Do we want to do the trivia question answer?
I think we can do the trivia question answer. So there were some people who didn't guess it right, so it's a little bit hard to mention. There's 3 of them. We had about 50 people or so, I think, do the right word at some point. So why don't you go ahead and can you read off the question again and let us know what the answer is? We'll roll for it.
So the question was, what type of command notifies the subsystem about the new set point as soon as that set point is set? And that type is immediate. The difference between immediate and immediate with deadband is that deadband does some checking to make sure your new set point is a valid set point.
And the winner for that is JRH154. JRH154, congratulations. You're going to get the AnyMark t-shirt. So nicely done, and thanks for being a subscriber, JRH154. We appreciate that. And make sure you shoot us a PM so we can get your information on the t-shirt.
All right. Awesome. So looking back at the live demo, we've set this up. We've got our climb case good now, but we still have this broken run arrow. So I'm going to click through and say, oh, I don't have a value for my for my immediate case. So this is the case where I'm holding the joystick and I want it to do something, right? So if I want to actually use this case, I can set it to 0. I can also wire it across just to give it a value. And then the last case is going to be that reserve case. Again, this is the one we definitely want to set to 0. Create constant so that whenever I call this reserve case, I know my forklift isn't going to go anywhere. Awesome, so we have that. Now if I want to send this data out to the dashboard, I can click that. You see that this automatically adjusts to now have a double instead of a boolean. And we are basically good to go down here in the controller VI. So you can see that down here in the lower right hand corner, step 4. This is where we're formatting that string to describe the command and how the previous command finished. You can see here right now we're just sending the set point and the duration. It's kind of the default of what we want to send through. So we're not going to adjust that, but you can format that string kind of however you want. You can also right click here. And if we want to create an indicator, I can now see that I have my set point out here on the front panel, and this will update live versus these here. So that's an option as well, but this is pretty much all we need in our controller VI. So we're going to go back to our Project Explorer. You can see we have a forklift folder now, and we have our commands and implementation. Implementation is down there. So you see that we don't have any VIs for the climb or the lift that we programmed into here. So we need to go through and make those VIs from those templates. So we'll just go through and do the lift template for now so you guys see how that works. So that was our immediate, right? If we go back here, we want it to send this value through immediately, but we're also getting that live from a joystick. So we're going to go ahead and use the immediate with deadband template so that it checks against our deadband value. Typically that's 0.01 to make sure that if our joystick is just sitting there, we're not accidentally getting any values from it. So right click, new from template. And so it goes ahead and makes this. The first thing I do when I make a template is I go ahead and save this as something useful. So I'm just going to call this forklift. Lifter. So forklift lift, because I like words twice. So now that we've renamed this to something useful, we'll be able to find it later. You can also click up here and change the icon so that it doesn't say forkle, because that's a nice word. We'll call this lift. So now this is a descriptive icon of what we're doing with this VI. Hit OK, it adjusts. It's already gone in and done all the work of setting up the setting up your inputs and outputs. If we tab over to the block diagram, you can see that it's also done the work of comparing to the deadband value, passing that command information in, making the calls over to the rest of the forklift system. There really isn't anything we need to do in here, so we can go ahead and save this VI. I just press Control S to save it. We'll close out of it. We'll come back to that in a minute. So now that VI is right here, already in the correct place in our Command and Control Project Explorer window. So if I wanted to actually do something with this forklift VI, I want to actually lift. So that's going to go in teleop, because that's something I want to do in teleop. So I can click on teleop, open that up. We'll go ahead and Control T to kind of nicely tile my windows. That's what I'm doing there. And you can see that teleop looks a little bit different than it does in our standard LabVIEW project. We've got these kind of case structures going on over here. This code is all going to be the same. We have included this nice handy little, I think it's called button values. This is a nice VI because it just gives you button values in and then turns them into button presses, but it debounces them for you. So we've already done the work there. Highly recommend using this if you are going to use a button press to indicate something is going for a long time, like we want to do with our lifter. So we're doing a couple of other teleop wait commands up here, but we want to add in our lift VI. So I'm going to go ahead and click on the little blue square at the bottom of this and drag it down to reveal more button options. So we'll say button 5. Well, button 4 is actually the button our lifter is tied to. So I'm going to go ahead and quick drop a case structure on here. So you can get to quick drop via Control Space, and I'm just going to search for case structure. And you can see that I get to it a lot faster than if I go through the palettes, which is pretty handy. So I'm going to go grab my button and wire it down, drag it over so it's a little bit cleaner. So whenever this button is true, the code in the true case is going to execute. Whenever it's false, the code in the false case will execute. Now I want to put my forklift lift VI in here, so I'm going to go back to my Project Explorer window. I can just click and drag from here. Ba-doom! There's my lift VI. It's a nice shade of purple, so I know what subsystem it belongs to, and it's easy for me to know what's going on here. So I can go ahead and set my set point. Now I wanted to do that from a joystick value, right? So I can grab, we'll pretend that there's a third joystick on here for now. You could go in and set up a new joystick. I'm not going to for time's sake. But we'll just grab this double value here, run it down. LabVIEW is going to make some interesting wiring choices there. There we go, that's not so bad. Run it down to my lift VI, and then I can set my deadband value here. Just going to create a constant. It defaults to 0.01. That's typically enough to correctly determine what's a deadband value and what's an actual joystick value that we want to use. It just keeps your motors from growling or creeping. So now we've set this. We can go ahead and give this a description. Go ahead and give it a name. So I'll drag this over here. This can go in or out of the case structure here. I'm just going to copy this by clicking on it and pressing by control, clicking on it, and then dragging. So I can rename this to forklift lift so that I know what command is executing here. This is particularly helpful if you're using, so these are the same drive VI. These are actually our drive for time, but these are doing different things. So this differentiates between this action, this teleop wait 1, and this teleop wait 2. I'm going to go ahead and wire my command info out, and then right click on this to use the default if unwired. This is one of the few cases in which we actually want to use the default if unwired. Don't ever use that in your controller VIs because you will get the wrong outputs at some point. And that's the implementation of your forklift lifter. We have just programmed that from start to finish using command and control. I could go back and do the same process for the forklift climb if I wanted to, and we would have that as well. I think that's kind of the end of the demo. Do we have any questions? Assuming we don't? Awesome. Cool.
Well, once again, I muted myself from stream. So no, we don't have any questions as of right now. Sorry, man, I'm scrub work right now. But if you have any questions, go ahead and message or type in @firstupdatesnow into chat, and we'll get those questions for April.
Cool. So we can probably go back to these slides now. Like I said, we walked through sort of the next 3 slides on creating a subsystem. So we can go. We did
just
the
to jump in too for everybody, we will be starting the Robo Reel giveaway soon, and that's going to be coming up in just a little bit. To make sure you do follow or subscribe to have an entry, and we'll have a keyword that you'll need to know on there as we come up. And this is the time, once again, we know that a lot of people watch with their entire team. This is the time, have one stream up, but get everybody in chat so they can be logged in and type in the keyword, because you'll have more chances to win that way. We do have a question, by the way, April, if you can answer from Lebensick1. Can you repeat the part about the wire defaults that you were talking about?
Yeah. If you want to bring back up the LabVIEW screen, if it's not still up.
Oh, give me just a second here. Okay.
Cool. So when I have this case structure over here, I'm going to put this back to the default. When this is defaulted, it'll be this little white square. I don't know if you guys can see it on your screen, but it's kind of hollow looking. And you'll see that I have a broken run arrow up here. If I click this broken run arrow, it's going to give me an error that I'm missing an assignment to a tunnel. One of the caveats of using a case structure is that you have to tell it what the outputs should be for every case, because it can't just say, oh no, I'm in the false case, I don't know what output to return from here. So you have to give it something. That's why it's giving you this error. So what we've done is right-clicked on the tunnel itself and selected Use Default if Unwired. What this does is it kind of gives you a little tiny white square in the middle of your tunnel. It's kind of half filled in, half not. This assumes that if you haven't gone in and manually wired the tunnel, you want it to return the default outputs for whatever that tunnel type is. So in this case, if I mouse over my lift and mouse over the command info out, you can see exactly what data types are on that wire. So this is a cluster. It's got a bunch of different data types in it, and those all have default values. So if I were to actually get to the false case, of this case structure, it'll return all of those default values without me going in there and wiring a default. Now, if I was really doing best practice and I wasn't being lazy and using the default of unwired, because it's definitely a lazy thing to do, I can go ahead and toggle that back off, tab over to my false case, and I can right click and create a constant. And it's just going to create a default value. It's the same behavior.
So, April, as a follow-up question, Levinstick asked, do you need to tunnel out of that output?
Yes, if you want to do something with it later.
What does tunnel mean, first off? Can you explain that a little bit?
So, tunnel is these little kind of blocks you see on the case structure outputs. That basically means that data is going from one side of the case structure, from inside the case structure to outside of it. We're tunneling through. You can get them on while loops, case structures, for loops, any kind of structure in LabVIEW you'll tunnel out of to send that data out. We just call them tunnels. These are here if I wanted to do another command afterwards. So if I was doing something with this lift and I was sending some relevant information back, like I'm at full capacity, and I wanted to send this to my drive VI, so I'm just going to grab this and bring it down here. I can wire these together, and they'll talk to each other. And so that's why you get into the habit of wiring them out of a case structure in case you wanted to sequence commands. You'll see the sequencing a lot more in autonomous. So if I were writing an autonomous code, now to be fair, this is in teleop, but if I were to write some autonomous code here, and I have, I made this small, I could have this case structure here, and then I could make another case structure here, and stick my drive, this is, what is this, drive for time? Drive for time in here, and actually wire this over. And then drive for time can react to what came out of the lift VI. That's why you get into the habit. If that makes sense.
Makes sense to me.
Cool. Do we want to do the keyword for the RoboRio?
Yeah, we can do the keyword and then get into the last couple areas, and we definitely want to check out any resources that teams might be able to get to as well. So, with that said, we are going to start the RoboRio giveaway. So once again, please make sure you either follow or subscribe. You do get a little bit better luck if you do subscribe as well, because we appreciate those who help support the stream, but we'd love to have you follow us and check out some of our other shows that we have coming up soon. And with the season starting, guys, we have a lot of content that's going to be coming out, and we definitely appreciate everybody supporting First Updates now. So with that said, we are going to do the RoboRio giveaway. April, what is the keyword everybody has to type in?
The keyword this week is resource. Like you said, we have a lot of resources available. So the keyword is resource. I'll let you get that on the screen.
All right, got it up there. You got resource, one word. So resource. That will get you a chance to win. And stay tuned. We'll draw for that in just a little bit.
Cool. So speaking of resources, one thing I did want to talk about, we did launch our new FRC resource hub on ni.com/FRC on kickoff. It's completely redesigned. If you saw the previous one, I'm sorry I made that. I'm not a web designer, but we had our actual web team work on this. It's so slick and so easy to use. I'm really proud of the way it turned out. We had a whole team here working on it, so hopefully that will be a great resource for you guys to use. It's got these great buttons on the front. If you're a rookie team, there's a button that says rookies click here. Start there. That'll walk you through our training and how to get going with your RoboRio and how do you install and activate LabVIEW. All this documentation is out there. So if you're having those kinds of questions and you can't call into the support line because it's outside of our support hours, or it's the weekend and we're all in our own individual shops, this is a great place to go and get the help you need if you're struggling with any of that. So that's at ni.com/FRC and ni.com/first now, actually. So you can get to it two ways, which is exciting.
Is there anything else on this website? So if you are a veteran team or anything that you'd find a lot of value to that they might need to access? And then you did mention as well that people can contact you pretty much any time as well, right, April?
Yeah, so right now during build season, our support line is open from 1 to 7 p.m. Central Standard Time. We are based in Austin, Texas, so we tried to pick hours that went East Coast to West Coast as best we could. Our forums are on there as well, our community board. All of our NI engineers, including myself, Jeff Ballard, Greg McCaskill, all these big names you know at NI are on those forums. We're happy to help you guys out if you have any questions. So that's a great way to get in touch with us. We also have all of our advanced content out there as well. The vision example for this year, if you want a super detailed command and control walkthrough, it's out there. It's like 10 PDF pages long. It's a really, really great walkthrough if you're interested in this, if this was appealing to you and you want to go through it a little bit slower, that's a great place to look. We're also going to be, I believe they're launching next week. We've created new badges for FRC, which I'm super excited about. This has been kind of a project of mine. So you can go and get certified in your FRC skills. There is a LabVIEW for Rio programming. So if you're really good at programming your robot in LabVIEW and you want a cool badge to put on your Chief Delphi profile, put on your Facebook, whatever, and say, hey, I'm really good at programming my Rio in LabVIEW, you can get that. There is also a hardware-specific software language agnostic RoboRio badge. We tried really, really hard to make this software agnostic, so it doesn't matter what language you program in. You can go to ni.com/FRC, take this test, and prove that you actually know the inputs and outputs of the RoboRio and know what they all do and what those values are. So I think those are really cool. I'm really excited to see how those go over. Hopefully it's a good, approachable way for kids, for you guys, for team members, for students, for mentors to learn and walk through the content we have out there. But yeah, ni.com/FRC, go check it out. Let us know if you like it. Let us know if you don't. We're happy to take your feedback. Can't say we'll change it because I kind of like it. But happy to take the feedback. No, in all seriousness, if it's valuable feedback, more than welcome to reach out to us.
Absolutely. April, was there anything else on the slide deck that you wanted to go over in particular for that?
I think that's it. I think the last slide is just the two command and control specific tutorials. Those are on ni.com/FRC or ni.com/first under advanced programming, I believe.
Awesome. So we're going to do the giveaway in just a moment here. Can we talk a little about what our next seminar is going to be and then the date on that, which is going to be the 25th. Is that correct, April?
Yes. So that'll be January 25th. Same time, same place, 7:30 Central Standard. And we're going to go over kind of all the little bits and pieces and tips and tricks of helpful LabVIEW things that just didn't quite fit into any of the other presentations. The main one we're going to focus on is source code control. I know that's a huge question for teams. Command and control lends itself super nicely to source code control because you do have these individual subsystems that just get stuck together at the end. So you can program subsystems on totally separate laptops and just bring that code into one main project. So we'll go through how to do that. If you want to interface LabVIEW with Git or other source code control providers, we can do that. We'll go through that as well. So that's the main one we're going to focus on. Some of the things you saw me use, Quick Drop was in there. We'll talk about that and just how do you become a more efficient LabVIEW programmer.
Absolutely. And don't forget, guys, with that coming up, they are giving away another RoboReel thanks to National Instruments, so that will be coming as well. That's going to be the last one for a little
last
bit.
Last one for a while.
Yeah, last one for a while. So I don't know. Maybe we'll work something else out. We'll see what we can get out of you guys in regards to giveaways, because we definitely appreciate it, and we know that everybody watching Fun appreciates it as well, April. So thank you so much for doing that. With that said, I think we should do the giveaway. You ready, April?
I'm ready when you are.
All right. And by the way, thank you to everybody who is subscribed so far and everybody who's followed. We got a lot more today, and that's fantastic. And do have actually one last thing. WTOTH1631 just want to state that the ask that we mentioned, how to make it so it doesn't ask to save a bunch of unrelated VIs when doing source control.
It's a good question. They're typically less unrelated than you think they are. When you edit something in LabVIEW, it gets that asterisk. the same as you see in Microsoft Word or anything like that. So if you edit anything that touches those VIs, so any controls, any other programs that might use those sub VIs, it's going to ask you to save them. It's kind of where we typically see that come from in terms of source code control.
And by the way, our friend, long-term subscriber Caltran in chat wants to know if you can give away a C Rio at any time as well. Do you get any of those?
C Rio?
Yeah.
Oh man, you talking about one of these?
Look at that, she's got one right there, guys.
This is mine. This is my desk ornament.
And when are you giving that one away? Your personalized one?
I'm not. But if you guys are really compelled by a C Rio giveaway, I will talk to the powers that be and see if we can scare some up for you guys. So
but maybe we'll have a side conversation about that later, maybe. So
they are not FRC legal, even if we give them away. You cannot show up with one of these on your robot. I don't even think you could connect to the field anymore, actually.
Probably not. All right, let's go ahead and do the giveaway there. And we did reset, so previous winners are also eligible as well, too. So congratulations. We're going to roll right now. Gray Phantom Delta, you won 2 things tonight. Holy cow, congratulations. You had, this is rigged, guys. If you're a sub right now, start typing rig in chat as many times as possible, because Gray Phantom Delta is on a roll right now and has won the Robo Reel. Congratulations, Gray Phantom Delta. I already have your contact information because apparently you win all the time now. So congratulations for that. And April, we can't wait to do another one of these in just a couple weeks. Looking forward to that. I want to thank you very much for providing your expertise for the stream as well. So real quick before we go, April, Power Up just came out. Can you just give us a 30-second before you tell me you were pretty excited about the game so far, right?
Oh, I am so excited about this game. You have no idea. I think the level of strategy that this game requires is awesome, and I think the level of flexibility and teamwork and cooperation and adaptability it's going to require out of teams once we get to competition is going to be so fun to watch. Just watching teams adjust to an ever-changing field and ever-changing scoring system is going to be really, really cool. I'm stoked to go to First Headquarters next week for FTA training. I'm hoping we'll get to see the field there, so that would be really awesome. But yeah, I think it's going to be a really fun, exciting game that I think we're going to see a lot more participation from teams across the board, which is awesome.
Yeah, we're looking forward to it, and can't wait to talk a bit more as well as we start going to the season. Don't forget, if you like First Updates now, just go ahead and click that little follow button right up there. We would definitely appreciate it. If you're really into us, go ahead and send us some love with a subscription to help us keep going. But all we ask, really, if you like it, just keep watching. Let other people know about it, that this resource is out there. We do a bunch of different shows ranging from game analysis, talking about FRC news, to pretty much almost anything you can think of. And if we don't have it, let us know. We'll get it on the stream. So on behalf of myself and April, I want to thank you for tuning in. Our next show will be on Monday with Candidly Speaking, which can't wait to have those new topics come out to talk about. And our next course, Natural Instruments Fundamentals of LabVIEW, will be in 2 Thursdays from now on the 25th. We wish you a good night, everybody, and thanks for tuning in. See you later.